parents, my name is Jasmine and today we'll be going through AIM as our skill focus for day 3. Okay, so firstly we have to understand what is the aim or the aim of the experiment. Okay, so after a hypothesis is formulated, okay, a scientist would begin to design an experiment to either prove or disprove a hypothesis. Now, what is a hypothesis? A hypothesis is a prediction statement. Okay, so the aim of the experiment would need to be established. So for example, if the hypothesis were to be, if a magnet is heated, it is going to lose its magnetic strength. Now we can see that this is a prediction. Okay, so the aim of the experiment would be to find out the effect of the amount of heat on the magnetic strength of a magnet. Now, as we can see, the aim over here clearly states what the scientist would be investigating. Okay. Now, when it comes to aim, there are several key components that would be included in the aim, and it would consist of the change variable, measured variable, okay, the key factor that is being tested. Now, this may not be always available in the question. Okay, so it is something that students will need to be able to infer, okay, in order to find out what is the key factor as well as the cause and effect relationship. Now, based on the aim over here, okay, we can see that the change variable is going to be the amount of heat, okay, on the magnetic strength of a magnet. So magnetic strength is not something that we can easily measure, okay? So the magnetic strength is actually the key factor that is being tested. Now, what is a measured variable? Measured variable is something that has to be able to be observed. Okay, so in this case, it could be the number of ion pins attracted after the magnet was exposed to a certain amount of heat, because the number of ion pins is something that we can observe, something that we can measure, we can count, we can record. Okay, and then over here we have identified our cause and effect relationship, which is the amount of heat and the change in magnetic strength. Okay, so today we are going to go through a little bit more on how we are able to infer the key factor that is being tested based on the given change variable and measured variable. All right. So in general, the aim of the experiment can be written using the following structures. Okay, so it always starts off as to find out. Okay, so to find out the effect of change variable on the measured variable, to find out how the change variable affects the measured variable, okay, or in some cases, to compare the physical property of a change variable. For example, to compare the transparency of different materials, for example. Okay. Taking a look at some examples, okay, we can see from non-examples to study sunlight and plants to find out about magnets. Now, these are way too vague, okay? It does not give us much information, much context to the question, okay? So they are definitely not something that we should learn from, okay? A better example, to investigate the effect of sunlight on plant growth to compare the magnetic strength of different parts of a magnet. Okay, so as we can see that these examples, they can be closely linked to the structures of aim. Okay. Now let's see sample question 1. Now, can you set ups P and Q below to conduct an experiment? Now, the plants in both setups are similar, kept in the dark for 48 hours before being placed in glass containers. Now, why must they be placed in glass containers? We can see that there is a sun in the diagram, okay? Which kind of tells me that sunlight is involved in this question. Next, when we compare P and Q, what is the change variable here? We can see that for P, there is a substance that absorbs carbon dioxide, and for Q, there is no such substance. So then, the next thing that students will have to do is to recall, what is going to be the change variable? Okay, so the change variable in this question is going to be the presence of carbon dioxide. Okay, in setup Q, there is presence of carbon dioxide. Setup P, there is no presence of carbon dioxide. So with that, students should be able to identify the change variable already. Okay. After 8 hours of being exposed to sunlight, a leaf was taken from each plant. Starch test is conducted. Okay. So what is the importance of a starch test? When starch is present, as we can see in P, this tells us that photosynthesis has taken place. Okay, because as we recall, for photosynthesis, we require sunlight as well as presence of carbon dioxide. Okay, so let's analyze the question in order to state the aim. So firstly, students need to know that sunlight is required for photosynthesis. Okay, identify the change variable, identify the measured variable. And from the change variable and measured variable, we have to infer that the key factor being tested is the conditions for photosynthesis to take place. With that, we will be able to write down our aim, okay? And the aim is as follows: to find out if carbon dioxide is needed for plants to carry out photosynthesis. Okay, so as we can see over here, our aim, we have to find out if the change variable, okay, is needed for plants to carry out photosynthesis. This will be the key factor that is being tested. Okay. So what we want to focus on for the students will be for them to be able to infer the key factor that is being tested. Okay. Now let's take a look at another example. Okay, sample question 2. Okay, circuit is connected to 2 metal plates after John partially submerges both plates into a beaker containing liquid P. The bulb lit up and he observed the reading shown on the data logger. Okay, he repeated the experiment with liquids P and R. Okay, so he's using different liquids. Now we have our change variable. All liquids used in the experiment were of equal volume. His results are shown in the table below. Okay, so now let's analyze the question together. So our change variable would be the different liquids, right? P, Q, and R. And the measured variable would be the brightness of the bulb. Now, students will need to be able to have the knowledge that the light bulb will only light up when the liquid is a conductor of electricity, if it conducts electricity. Okay, as we can see for Q, the bulb did not light up. Okay, so this will also tell us that liquid Q is definitely not a conductor of electricity. Okay, identifying the key factor that is being tested would be the electrical conductivity of the liquids and not just writing different liquids. Okay, students must be able to understand that the key is electrical conductivity and not just writing to find out how different liquids affects the brightness of the bulb. Now that would be too vague, that would be incorrect. Okay, so correct answer would be to find out how the electrical conductivity of the different liquids affects the brightness of the bulb, which is our measured variable. Okay, so again, to find out how the change variable affects the measured variable. Okay, so some helpful tips for writing the aim of the experiment. Firstly, identify accurately which is the change variable, which is the measured variable. Okay, and based on these information, infer the key factor that is being tested. Okay, definitely this would require more practice, okay, and more learning for students to be able to be more confident in conquering these forms of questions. Okay, and also to use the correct format to write the aim, okay, which is the answering techniques that will be gone through during our weekly lessons and reinforced in weekly lessons as well. Okay, lastly, practice, and more practice. So use experimental setups to practice writing experimental aims, even if the question is not specifically testing on the aim of the experiment. Okay, sometimes in lessons, we still add on extra questions for students to be able to reinforce their learning. okay, and for them to get even more practice for important questions with answering techniques such as their aims, relationships, and so on. Okay, so parents, I hope that you all have a better understanding on answering questions relating to aim. Okay, and I hope this lesson was helpful and hope to see your students in class. Bye-bye.